To you, Erica. Okay. 4.3a, excursion section. It's a shorter one. There's only 2 examples, but it does take a little bit of time to enter stuff into your calculator. All of what we're doing today is calculator stuff, okay? So that's why I kind of have him off to the side over here. We need to take and enter this guy into a table, okay? And I'm going to show you how to do that. But they want us to basically enter that data into the table and say, calculator, make me an equation for this data, okay? And the things that we want it to create, it says the following data, which is based on statistics from the Department of Health and Human Services, gives the cumulative number of reported cases of AIDS in the United States from 1982 to 2000. Kind of morbid, whatever. They want us to find a quadratic function, a cubic function, a quartic function. I'm really delayed. And determine which one is the best fit. Okay, so find 3 equations: quadratic, cubic, and quartic. I'm writing these down below here. I know you can't see because we're really delayed. There you go. Okay, it all like zips up at once. Quadratic, cubic, quartic. We're going to write out 3 separate functions. What does a quadratic function look like? Nope.
It looks like a W.
It looks like a, no. Quadratic is x squared. Cubic is cubic, x to the 3rd. Quartic is
why is it so delayed?
x to the 4th. I don't know. So we're going to write each one of these and see what he looks like. Okay, quadratic, cubic, quartic. All right. So the first thing that we want to do is identify how we're going to enter this into our calculator. So each one of these years are the x's and these guys are the y's. The reason why they have 3 separate columns is so that we don't have one column that goes all the way down to the bottom. They're trying to save room. Does that make sense? Yeah, do you see how this is working? Okay, they have the x's and y's over there. So they don't want one column that's going all the way down to the bottom. Oh, man. One column going all the way down to the bottom, so they separate it down to 3 separate columns, okay? The x's and y's, we're going to enter those into our calculator, but sometimes it is faster and easier to, instead of listing this first one as 1982, let me get it to zip there. Instead of calling the first one 1982, to give it like year 0 or year 2, we could say, right? So let's decide how we want to identify each one of these years. Do you want to call 1982 year 2, maybe, to make it easier? We could call it year 0, but it's kind of nice to have year 0 be a 0 year, right? Does that make sense? So what we're going to do off to the side over here is I'm going to say x equals 0 is 1980. Okay? I'm sorry. X equals 0 is 1980. All right? So what we want to do is, rather than entering 1982, 1984, 1986, 1988, we want to designate those as the year that they're supposed to be.
So this one is 2.
So I'm going to cross out 1982 and I'm going to put 2 in there. 1984 is going to be year 4. So cross each one of these out and put in the years that they're supposed to be. The first column should be 2, 4, 6, 8, 10. Okay? What about the start of the second column? What will he be? He will be 11. 1992 is 12. 93 is 13. 14, 15. Sorry, it's taken forever. Okay, the last years, 16, 17, 18, 19, and 20, right? Good to go? Now we're going to enter those numbers into our calculator. Before we do that, it is very, 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 very important that you type these numbers in exactly the way that they appear on the table, because otherwise your equation is going to look different than ours. So after you enter each one of them in, you're going to enter in first the x's, then we're going to enter in all of the y's. You need to make sure that all of these numbers are entered in perfectly into your calculator. If you finish typing this in before I do, check your numbers over to make sure that they match, okay? Here's how we enter them in. You're going to go to Stat, Edit. These are your steps, okay? We've entered these in before. So go over here to your calculator, the Stat button.
How do we clear it?
On Stats.
I got it.
Okay, go to edit. If you want to clear them all out, you can go up to that heading. Like I have stuff in my L2. I can go all the way up to L2 and click clear, click enter, and it will clear all 4 of them out at the same shot. Okay? So it says whatever. You want to use it now? Oh.
That's gonna get caught so that
Okay, so typing these in. L1, you got to type in all your 2, 4, 6s and stuff. 2, 4. I don't know if this is going to go. 4. Enter.
I thought you just let us do it.
But then they can't see on the screen what I'm doing.
So just tell them to do that, and then that's it.
You type in 11
What'd you say? Type in all of those, so all 15 of them. Yep. 6, enter. Oh boy. Enter. This is not going to go well. 8. Enter. Yeah, it wants to just like suck all the juice out. 10, enter. 11, enter. 12, enter. Oh, there we go. We're kind of catching up. 13, enter. 14, enter. 15. Go back through and check yours to make sure you get the right numbers. 16. Enter. Oh, Lord. If you're watching this video, skip ahead. 18. Oh, my. 19. Enter. 20. Enter. Oh, Lord. All right, did you guys enter your L2s or your Ys? Do that right now. Make sure your Ys are entered in correctly. This is going to really take a long time.
You're just.
Yep.
I'll just sit you in a way.
1, 0, 8, 4. 0, 8, 4, 5, 5. Enter. 41, 6, 2. Enter. 1. Oh, 5, 4, 8, 9. No. One. 88. 8, 7, 2. Three, 8, 0. Did you double check? And triple check? Quadruply checked? You're sure? Seven, 8, 9. Enter. Five, 2, 8, 4. Is this painful to watch? as painful as it is for me to type this in. It is. 5, 9, 5. Is that 559? Enter. 6, 5, 2, 4, 3, 9. Enter. 6, 9, 8, 5, 2, 7. Enter. 7, 4, 3, 4, 1, 8. Enter. 7, 8, 4, 5, 1, 8. Enter. Done. Okay. Are we ready?
Yes, ma'am.
All of them are typed in, ready to go?
Yes.
Okay, we're going to say, calculator, make me an equation, go. And the first one that we want is a quadratic function. Okay? This data, if you graph it, looks like this. Do you think a quadratic function is going to be a good approximation for this data?
No.
What does a quadratic function look like?
A U.
A U. Does this stuff look like a U?
No.
Even like half of a U?
No.
No. A cubic function.
Yes.
Do you think that might be a cubic function?
Yes.
Maybe. A quartic function might be okay if we're talking about like the middle piece of the quartic function, right? Okay. You think it's quartic? So what we do now is to make an equation, go stat, and instead of edit, we go over to calc. And we go down to, we did before linear regression. Do you remember doing that? Stat, calc, linear regression. We want to go down to quadratic regression. Cubic is right below that. Click enter. It's saying, if you hit enter, do you want your x's to come from list 1 and your y's to come from list 2?
Yeah.
Yes? So go enter. I'm coming. Calculate, and then it should spit this whole big, ugly, long thing out. Did you get it? We want quadratic first. Quadratic first. Go ahead, enter. It's saying you want your x's from list 1, y's from list 2. Yes, we do.
What?
Okay, and it's going to take a second to think, and it's going to spit stuff out, and it's really gross.
How do you, wait.
Really gross and ugly.
One more time for the people in the back.
One more time for the people in the back.
Why does it have R?
We'll get to that. Okay, stat. Calc.
Oh, okay.
You want them from list 1, list 2? Yep, yep.
Why does it have an R? I love it.
Okay, that's not what we want. We want to look at back, we're going to do, so 81 this one is your stats. So you're going to look back, you're going to do
Wait.
and then all you.
Wait, Tegan
Okay.
doesn't have an R.
That's fine. We'll get there.
Okay.
If you don't have an R, that's fine. Okay, so quadratic. It spit me out a quadratic function.
You go down to calculation.
Then you didn't double check and triple check your numbers.
I got it.
You did? Do you have the same numbers as me?
Yes.
Yeah? Then you didn't double check and triple check your numbers.
Yeah. What if I did?
I don't know. All right, so the way that this is set up in my calculator, it says y equals, check this out, y equals ax squared plus bx plus c. Isn't that what it says? The top thing in your calculator? That's what it says. And then it says down here, check this out, exclude the r, it says a, b, and c. So a is this number, b is this number, c is this number. So we're going to write that in. Y equals, my A is 1757.9. Let's go 1758. X squared, that's what A is. B is 989.29 plus 989.29. X. C is negative 59024.31. Okay, I am entering in this ABC from here into that equation. Does that make sense? Do you see what I'm doing? I'm writing out ax squared plus bx plus c, but putting those guys in there. Make sense? Good?
Yes.
Okay, now, I'm going to also write down, my thing says an r squared of 0.9856. Here in a second, I'll show you how to get that r squared on there if you don't already have it. Okay? But I'm going to write down r squared equals 0.9856. Good?
Yeah.
The r squared is 0.9856. Okay, I'm going to put that off to the side over there. Separate from the function. 0.9856. That's what my guy is right here. 4 decimal places. Right? All right, now we're going to go again. We already have our data entered in, and we're going to have it do a cubic function. So stat, we're going to go over to calc. We're going to go down to cubic regression. Very slowly, but we're going to do it. Okay, cubic regression, L1, L2. Calculate. Stat calc, cubic regression this time. Stat. It's going to take a second to think.
Where do you get
I'll get that on your calculator here in just a minute. So just write down mine and then I'll show you how to get yours. Okay?
Okay, I got one.
All right, now cubic regression has 4 numbers, A, B, C, D. We're going to enter in all A, B, C, D in there.
Can you screw it over? Plus C?
Oh, you mean like that?
Yeah, I just can't. Is it plus C?
Yeah. Okay, so your cubic numbers. I'm going to click on here. Cubic numbers, y equals, we have a x cubed, and my a is negative 219.18. Negative 219.18, and that's x cubed. X squared is 9111 plus 9111.66 x squared. Do you see where I'm getting these numbers from? C is negative 59991.75, and that's x. And then I have one last one plus d, which is 103255. Let me write that again because that was really gross. 103255.32. And r squared is 0.9964. Okay? R squared, 0.9964. I'll show you here in a second how to get your r squared on there. Okay? Last one is quartic. It's going to be the longest one. Okay, do you know where you go to get quartic?
I have a G. I have A, B, C, D.
Yeah, because it's x cubed now. So we have 4 pieces instead of 3 like we did in quadratic, right? He starts with x cubed because he's a cubic function, right? Quartic is going to have 5 pieces, so it's going to have A, B, C, D, E. It's going to have all of them. So quartic, y equals. Okay, you go ahead and fill this in. You know what you're doing now? Stat, stat calc, go down to quartic. Enter.
What is, it's AX cubed plus what? So it's AX squared?
Let me get mine going. Maybe. There we go. Okay. What's one? Oh, it's just the inside stuff. So, like, this is ax to the 4th, bx to the 3rd, 2x to the 2nd, dx to the 1st, and this d. Right? It goes down in order. Right? Does that make sense? Okay. All right, so this one, really long and ugly. A was negative 20.29. x to the 4th power this time, b plus 681.94 x to the 3rd minus 4318.57 x to the 2nd power plus 15550.81 x minus 17877.25 r squared point, I gotta go down, 0.9986. Holy cow, that was a lot of work. Probably wouldn't have been a lot of work if my calculator wasn't so slow, but that's okay. Did you guys get these guys? Yes? Those are my equations.
Now for the r squared. Oh, wait.
All right, who needs an r squared?
Oh, okay.
You need an r squared. There you go.
Okay, this is it.
Yeah, the only one I didn't get done was zero.
Okay, just go all the way down. It goes alphabetical order, and it says diagnostic.
Got it.
There she is.
Okay? Anybody else missing an r squared? Tegan?
That must be behind you, Andy.
Okay? All right, good to this point?
Sorry, I'm being disqualified. Oh gosh.
We're gonna stop there.
We're gonna stop there. Kind of. We're gonna do one more. We're gonna do one more thing.
What was it? Mrs. Kennedy.
All right, we have our 3 functions. The r squared, you guys know how to get it now? It should be on all of your calculators, but your r squared value tells you what % of your data fits that equation. So which one is the best?
Quartic.
Quartic has the highest percentage. It's 99.8% of your data is fitting that equation, yeah?
Yeah.
So we want to use the quartic function.
So
Which one
it
is the best?
So it's quartic?
Quartic.
Oh, guess you did.
Okay,
So
now.
we really wrote that out for no reason.
Not necessarily, because you can use the other two. It'll give you a good approximation, okay?
I mean, no,
Now,
could we just write up an r squared? Like, could we write up that whole equation for no reason?
well, they wanted all 3 of the equations, so that's part of the answer is all 3 of them. But it's just showing you that the r's one is better. Okay, so quartic equations, the one we want to use. Don't put everything away yet. Here's my follow-up question. We're not going to do example 2 yet, but follow-up question. Use quartic equation to estimate, what are we talking about? The number of cases in, let's go 2020. So according to this equation, how many cases should we have in the year 2020? All right?
Wait, what?
How many cases should we have in the year 2020? And we're gonna figure this out.
So we're not
The
doing
center of
number
the
two.
equation.
No, this is all just number 1.
Just keep plugging it in.
Right, so we have to decide what we're going to plug in, right? We have our equation. This is our big long equation that's really gross and ugly for our quartic function. And we have to decide what we're going to plug in. So we're going to plug in for x, but do we plug in 2020 in for x? No. What do we plug in for x? Okay, 2020. 2020. The x is equal to 40, because if x equals 0 is 1980, then 2020 is 40, yeah? Okay? So we're going to take that guy and we're going to plug 40 into that big long function that we have. That's really gross. Okay? I'm going to steal MJ's calculator and I'm going to do that. Okay? If you guys want to verify this, you sure can. Plugging in. I'm plugging in 40. I'll do that for you. Okay? Plus 681.94 times 40 to the third power. Okay, whoa, what I got, 2020, if I plug 2020 in, oh my, this is a mess. I got negative 14,603,829.25. What in the heck does that mean?
That is not right.
We had a negative number of cases. We had a negative number of cases.
26.
Okay, so what this means, obviously we can't have a negative number of cases because that would mean a negative number of people, right?
Yep, we're all dead.
If we use this to estimate in 2020, what they're saying is by getting a negative number, it's probably not a good estimate for years that are on the ends, right? On the end, like 2020 would be all the way out over here. We probably could not use it to estimate that far into the future, okay? So let's look at this table just one more time before we stop. 1982 and 1984, what I could do is I am missing the year 1983, right? So it might be a very good estimate to plug 3 in and get a good answer out, but probably not very good to estimate the year 2020 because 2020 is all the way too far in the future, okay, for this graph to estimate. Make sense? Ish? Okay? So even though this quartic function is a good equation, it's only a good equation for the data that I have there. 2020 is probably too far in the future to estimate, okay? Because we got a negative answer. So the point of doing this is on your homework, they'll have you do a problem here and find the function, and then they'll have you plug values in like we did 2020. But 2020 wasn't a very good value to have you plug in, okay? All right, we'll do example 2 tomorrow, and then we'll stop. Okay? There you go. We'll do example 2 tomorrow. All right, and then we'll be done.